Patrick Cook here. Welcome to session number 27 of our Mandelbulb3D Epic Rendering tutorial series. I know you think this is a lot of fun, and it is. It is, because these tools give us the ability to go big. Even with memory limitations, we can go big. I could probably do 100,000 pixels by 33,000 pixels. I could do that. I can do it. Do I need to? Well, it depends upon my goal. All right. But the beauty about this thing is that this Big Render tool is giving us the capability to work around the memory limitations that are inherent, well, with all applications in a Windows environment. An application can only get so much memory from the Windows operating system. Even the more advanced current applications are going to have a limitation. That's what the Windows operating system does, is it regulates resources out to these applications. A big reason for that is because the Windows environment, as the name suggests, is a multitasking environment where the operating system's primary job, believe it or not, is to allocate resources. It allocates what are called threads, all right, cores, and it basically says, look, I've got 5 applications running. You can have some threads. You can have some threads. You can have some. Oh, you get really busy? Let me give you some more threads. And this one right here is idle, so it gets less threads. And this whole thing happens magically in the background. All right, these 5 applications, all of a sudden, the Mandelbulb starts up here, and he wants to put a whole bunch of his code in memory. So Windows says, okay, I'll give you some memory that you can store your code in so you can run your program. Here's 900 meg of RAM for your code. There you go. And it's up to Windows to keep track of all of that. There's a Mandelbulb here has got 900 megabytes worth of memory for it, just its code while it's running. All right, it comes along and it says, hey, I got a picture I got to make for Pat there. And Windows says, okay, how much do you need? And the application says, well, I think I can do this job with maybe 100 megabytes. All right, so Windows says, here's 100 megabytes. All right, another application comes along and says, I got something I got to do too. And Windows says, well, how much memory do you need? And it says, well, I need 6 gigabytes. And Windows says, I can't do that for you. It's too much. You don't need that much. All right. And then we're kind of pretending that Windows and these applications talk to one another like this, but they don't. But they kind of do by exchanging information. So Windows says, I'm sorry, but I can't give you 6 gigabytes. I'm just not going to give you that amount. I suppose I could, but I'm not going to. And the application says, oh man, I knew my developers should have used threads, where the application will split off its own internal tasks and try to regulate the amount of memory that Windows will allocate to it, rather than trying to take gobs and gobs and gobs of memory. Because Windows is going to say, look, you're being a hog. You can't do that. I'm not going to let you do that. Another application comes along here and has an intensive calculation, and it says to Windows, look, I need all your cores. And Windows says, I can't give you all my cores, because I got three other applications running. All right, you get the picture. This is the kind of stuff that goes on. So what I'm trying to say is this: that your Mandelbulb application has only so many resources it has to work with, and it's a beautiful thing that they actually installed or designed into Mandelbulb the ability to get past these operating system limitations. These operating limitations are not as bad or as strict as they used to be back when Mandelbulb was created, 2010, 13, somewhere in that area. They've relaxed more, and there's more sophistication in the Windows operating system. So it's very fortunate that we have the ability to work with the Mandelbulb and get out a large, high-resolution native rendering. Native. That means not upscaled, not downscaled, not fooled around with, not faked. Native. Every pixel that Mandelbulb creates in the image is what I refer to as native. And we don't fake it. Now, all right, so, but I digress. Let's get back to our job here. All right, now there's another aspect to this that we need to pay attention to, and it's called ambient shadowing. All right. Now let's close this so I can show you. I'm going to come over to Post Processes, and I'm going to pull down this thing called Ambient Shadow. All right. I'll tell you what. Let's get this over here. That's good, right there, where we can focus on it. We have here a couple things. First of all, this calculate AS automatically simply means that when the main program has rendered, it will automatically go back and calculate all of the ambient shadows for that scene magically. AS stands for ambient shadows. Now you notice here that we've got four tabs, okay? Now this SSAO, it stands for Screen Space Ambient Occlusion. That is a method of calculating ambient shadows. It's a method. It's an old method. It's still around, but it's been improved upon, and it's old. It's old. I don't know what the 15, the 24, and the 24R are. I don't know. I tried to research it, go way back, try to read up on the fractal forums, and nobody seems to have offered what those 15, 24, and 24 are. They're obviously versions of the SSAO, all right? But we don't need to pay a whole lot of attention to those anyway when it comes to big renders, because those SSAO ambient shadow calculation methods are not used, cannot be used for the big render. Only the DEAO can be used for the big render. I haven't read anywhere that they're describing why that is, but I have a pretty good idea. The DE does refer to distance estimate. AO obviously is ambient occlusion. All right, so the DEAO is the only method that will work for ambient shadows with the big render, the tiling. Okay. Let me prove that to you here. I'm going to put this on SSAO 15. I could do 24 too, it doesn't matter. Let's open up the Big Render. Big Render. Now I'm going to import the actual params. And if I'm right, we're going to see a message pop up. There it is. It says, keep in mind now, I've got SSAO selected over here. It says only DEAO ambient shadows available in tiling mode is now selected and set to 33 rays. Please change it at your own needs. Okay. All right. So what this has done is it has rejected my SSAO and it has forced me to use the DEAO in my tiling configuration. I'm not seeing that over here because I need to send my original parameters back to the main. Now I'll go ahead and do that. Now we should see the DEO get selected here. Send original parameters to main window. There we go. You notice how the DEO was selected now? Okay. So this session, we introduced the fact that only the DEAO ambient shadows methodology will work for the rendering of tiles. Okay? All right, we'll pick this up in the next session. I'll see you there.